here's the big important thing. If these intervals aren't, if you're not using these intervals, then these properties don't apply. But it should make sense to you that if sine and arcsine are inverses of each other, if you take the sine of arcsine of x, do you agree that normally inverses undo each other and you just get x back? And the same thing if you switch it around, if you take the arcsine of sine of y, then you would get y back. We're going to look at some examples of these, and sometimes it's really easy because you just can do exactly what's there, like it just cancels out. But if it's outside of this range, right, what if they threw in like pi in there? This doesn't apply anymore, and so you have to actually work it out, and maybe it's just good to work it out anyway so that you don't mess it up. But it's just about undoing it. And there's one of these for all of these. It's up to you if you want to write it all down. I'm going to show you the other two as well. But cosine and tangent also, if you take the tangent of arctangent or the cosine of arccosine, if you're in the specified range, then a function and its inverse will always cancel each other out. The good news is, if you don't remember this property, you can always just work this problem out. Or if I give you one that you seem like you can't work it out, hopefully maybe you'll kind of remember, you know, if you do any function and its inverse, they'll cancel each other out. If you take the square root of something squared, if you take ln of e, those are inverses of each other. Okay, those kind of cancel each other out. Which means some of your homework tonight might be also pretty simple. Like this chapter's kind of backwards, whereas most chapters you start off pretty easy in the beginning, and then the end of the chapter kind of gets a little crazy. And this chapter has been kind of rough. And in the last couple sections, I feel like are the these aren't so bad sections. Maybe. Yeah. Mostly because it's not graphic. We were discussing in Food Now yesterday that we started chapter 4 on the first day of school for this semester. And here it is, February 13th. And we're still on chapter 4. Tomorrow is now Wednesday. Wait. I just realized. Can I go? So let's look at a couple of these. Just like anything, they give you a problem like a function inside of a function, you can always just work that out. Which means if I forgot the property here, I could look at that and I could say, well, I'm going to forget about this sine part right now, and I'm just going to do the inside and get the answer, and then work my way out to the outside. Maybe we can look back at that previous one. Let me go back just a second so we can see it. For arcsine, if x is between -1 and 1, then this property applies, which means I think for number 1 there, if you recognize that, hey, that's in the domain, I should just get 1 back. You don't have to do any work on that. Like, you can just say, I think it should equal 1, because they cancel each other out. Why is that true? Let me show you, because sometimes you're going to have to actually do the work. If I'm doing this part, do you agree that's what we did yesterday? That's like saying sine of what angle equals 1? What angle in our negative pi halves of pi halves has a sine of 1? Sine is y, right? Pi halves. So do you agree that I could replace the inside of this with pi halves? Because because the arc sine of 1 is pi halves. And then I just do the outside. What is the sine of pi halves? It's 1. So it really does work because I just get 1 back. Do you have to do this work? Nope. You could just tell me that it equals 1 because of the property. But be really careful because if what they give you here is not in that specified domain or range, then it's not going to always be exactly what you get back. Like number 2. Number 2 says, find the arc cosine of cosine of 7 pi halves. And you're right, arc cosine and cosine should cancel out. But is 7 pi halves in our specified range for arc cosine? For cosine, it's 0 to pi, right? So this is an example of one that you can't use the property. You have to just work it out. And so maybe you just want to work it out every time because it's not that much work. Start with the inside. Can you tell me, or can you figure out how to find what the cosine of 7 pi halves is? 7 pi halves. That's bigger than 2 pi, right? 2 pi would be how many halves? Two pi equals how many halves? 4 pi halves, right? So normally I'm like 0 pi halves, pi, 3 pi halves. If I count this as 4 pi halves, could I count this as 5 pi halves, 6 pi halves, 7 pi halves? So do you agree that 7 pi halves is down here? And what is going to be the cosine of any point down there on the y-axis? 0, because cosine is the x, which means I could replace this with 0. And then this is exactly what I did yesterday on my homework, hopefully. Now I'm going to do the outside. Now can I find the arc cosine of 0? And this is where you're asking yourself, what angle has a cosine of 0? Or you could rewrite this as the cosine of what equals 0. You can't say 7 pi halves because 7 pi halves is not in that interval. Because for cosine, what is the interval you have to give your answers in? 0 to pi. So what is the only angle between 0 and pi that has a cosine of 0? Pi halves. And so you have to kind of think on these sometimes, or just work it out. Like start with your inside, do what it says, and then work your way to the outside. So my advice to you on this is just be careful. Like don't automatically just say, oh, the answer is 7 pi halves. Because if it doesn't fit in the range, you have to actually work it out. I think I got one more on here for you to do. As a check here, let's see. Wait. Oh, 2 more. Oh man, what did I do on this one? I changed it up, didn't I? Does this match one of those properties? No, because it's definitely not canceling each other out, because one is a sine and one is the inverse cosine. But it's the same idea. See if you can start with the inside there and tell me what angle makes that true. And then you're going to take the sine of whatever answer you get there. So some good review here before we have a test. See if you can figure that out. What angle has a cosine of the square root of 3 over 2 in our specified range? And if you need to look at your unit circle, if you need to draw a triangle, right, this is what you should be doing when you're working these problems out. Anytime you're doing an inverse, you have to worry about the range, right? Because there's lots of angles that have a cosine of square root of 3 over 2, but you better give me an answer that's between 0 and pi.
Always that?
For cosine it is, right? But for inverse sine and inverse tangent, what is it always? Negative pi halves and pi halves, right? So I think Justin said already, cosine of what equals square root of 3 over 2? It's either going to be pi 6 or pi thirds there, and if you are a unit circle person, the order of pair here is square root of 3 over 2, 1/2, right? And this one's 1/2 square root of 3 over 2. I feel like I've been a triangle person lately for all you unit circle people. I can't help it. But cosine is the x, which means it would be pi 6. Pi 6 is not your final answer. That's just what you put in here. So now you can say I have the sine of pi 6, and you have to actually work that out. And what is the sine of pi 6? Oh, look, I have it right here. It's the y value, which is just 1/2. So it's kind of like a 2 problems in one. You have to do the inside function and get your answer, and then you have to work your way out to the outside function. Really important that you pay attention to whether it's inverse or not. When they give you the inverse, your answer is always an angle. If they give you not the inverse, your answer is the value. And so whatever's the outside part will be what your answer is. Like, look at this one. Same idea, but I've switched it around on you. Now I put the regular function in the inside and the arc sine on the outside, which means, is your final answer going to be a value, or is your final answer going to be an angle on this one? An angle, because the final thing you're going to do is the inverse stuff. So again, take a minute. Do the cosine of pi thirds. I just kind of drew it up here on a unit circle for you if you're a unit circle person. And then take the arc sine of that. Again, not a huge amount of work on these today. It's just kind of thinking through them as you're doing them. Nope. This would be no calculator, because what is the cosine of pi thirds? Right, the cosine of pi thirds would be the x-coordinate there, which would be 1/2. And then this is like what you did yesterday on those first like 12 problems. This is saying the sine of what equals 1/2 between the specified range of negative pi halves to pi halves. And that would be this angle, right? So the answer would be pi over 6. The only time it would be a calculator problem would be if it's not from the unit circle, like the ones on the last part of your homework. Questions about that? The only other thing from 4.7 is now looking at solving some problems with x in them using this same idea. So let's see if we can look at a couple of those. So on this one, they're not asking you to find an actual answer. Notice there's an x in the problem, and it's kind of saying if you understand what this is representing. And basically, I say we're just going to go back to our triangle stuff, our opposite over adjacent, and all that as we're doing this. And they always write it as like a double thing, like this one, the tangent of arc sine of x. Just like the other ones we were doing, don't really worry about the outside part yet. That's going to be the final thing that we do. We're going to use this inside part to help us draw a triangle. And then we can figure out from there. Okay, so I drew a little triangle already. I'll let you draw one too. And this is where what I've been saying, like how you rephrase this question every time, how this comes into play. So when it says the arc sine of x, do you agree that the definition of arc sine, this is the same as saying the sine of some angle equals x? Agree that that's what this is saying? Or could I go even further, and instead of calling it a question mark, since we're going to label a triangle, can I call that just theta, or whatever you want to call it? I'm going to call it theta. And if I'm thinking about labeling my triangle, could I label that as x over 1, like as opposite over hypotenuse? And so again, it kind of comes back to the, do you know the definition of arc sine? So over here in my triangle, can I pick one of these little angles and call them theta? Whichever one you want. I'm just going to pick this one. It doesn't matter as long as you label it correctly. If this is theta, and I know that the sine equals x over 1, could I label that opposite side as x and the hypotenuse as 1? I don't know what x is, which is why the question doesn't say, like, give me an exact answer. Your answer is going to have x in it. You're going to get an algebra expression back. If I know two sides of that triangle, can I do Pythagorean theorem to find the third side of that triangle? Yes, in terms of x, I could say that I could find this side, and it's just going to be, what? X squared plus, I'm just going to say b squared equals 1 squared. B squared equals 1 minus x squared, or b equals the square root of 1 minus x squared. I also use that whole r equals the square root of x squared minus y squared. I didn't want to do that, but so I could label this side as 1 minus x squared. Every time on these problems, the inside part is going to give you enough information to fill out a triangle and find the missing side. Then, just like we've been doing, can I go back and find what they're asking me on the outside? I don't know what theta is, but do you agree that this is going to equal some angle theta? Like whatever this is what I would replace here. Like on the last one, if it was pi 6, we plug in pi 6 there. So could I just say now I'm trying to find what the tangent of theta is? And can you look at this triangle and tell me what tangent is? How do you find tangent? Opposite over adjacent, which means I'm just going to write tangent as x over the square root of 1 minus x squared. And you don't have to rationalize your denominator on here. We could, but it's just going to kind of make it a big mess still. You can rationalize if you want, but this is the one time I'm going to say, because we just have x's and we don't actually have numbers in here, you can leave your answer like this. I just want to know that you understand the trig part of it more than the rationalizing your denominator. So today's more of you taking this idea and applying it to some other stuff. So let's do another one of these. I'm going to let you kind of do another one of these. It's going to be just like this. Anytime you see all things. Again, the directions are find an algebraic expression for this. And every time, you're going to want to rewrite that and draw a picture to match it up. So if it's asking you for the inverse of this, I'm just going to get you started on this first step. I could say that the sine of some angle, theta, is equal to 2x over 1. Do you agree with me on that? So what I want you to do is take a minute and see if you can label a triangle and solve for the third side, and maybe even go ahead and do the outside part. Make sure when you square this side, you're squaring both the 2 and the x, right? Like it's not just going to be 2x squared, it's going to be 4x squared, right? When you do Pythagorean theorem. Yes? Just swap the pictures. Right? It's not going to be 2x squared. Make this square root of 2. Technically 4x squared. Did you get that for your third side? 1, the square root of 1 minus 4x squared. And so then what do you do after that? What's the last step? do whatever's on the outside. So now we're going to take the cosine of that same angle, and it's up to you if you actually write it out or not, but basically what we're doing is we're going to take the cosine of this, which would just be this over 1. I would never leave my answer over 1. It would just be the square root of 1 minus 4x squared. And so that one's definitely, calculator doesn't help you on a problem like that. It's kind of saying, do you understand the whole idea of doing those trig functions together? Well, that's like the shortest notes we've ever had ever. Come on. Mm-hmm. Yep. So if they gave you a fraction, yeah, you could just take whatever the bottom is as your hypotenuse. Hopefully, maybe this isn't going to be so bad. So I'm going to give you some time to work on your homework. This is 4782. 24 through 32 even. And then 47, 48, 50, 51, 52, 61, and 62. You should be able to get a really good start on this day, if not even finish it all. I have those worksheets that you turned in. I don't even know what day it was. The day before yesterday, I think. I'm going to pass those back so you can look at them. And if you have a question on something, please ask me, because there were definitely some issues with graphing. Like on secant and cosecant, lots of you are making those parabolas touch the x-axis. Remember, they're never going to touch the x-axis. Right? Like if you have sine looks like this, secant, cosecant is always going to start at the top of that curve. Right? There's going to be a gap there, and lots of you are making those parabolas touch the x-axis, so you need to make sure that you look at that if you're doing that, because you don't want to do that on the test. So definitely ask